Another type of connection that you're going to frequently encounter with Windows 10 is a remote access connection. These are network connections that aren't local, but instead they're made remotely to a corporate office by mobile clients or possibly to cloud-based virtual networks. More and more organizations are hosting networks in Microsoft Azure and then providing access to those networks for mobile clients. And so the mobile clients then are not connecting to an on-premises VPN server, but instead are connected to the cloud. It's an easy way for an organization to offload, what they've got to the cloud, offload that infrastructure, but still provide the functionality. Two primary means of communication via remote access in Windows 10 are the virtual private network and direct access. And so in this section, we're just going to go through the different types of VPN connections and then try to get you a good initial understanding of the direct access alternative. We'll begin with virtual private networks. And VPNs have been around for a while. They've been the most appropriate method for remote access connections for years due to the significant advantages that they have over dial-up connections. Of course, dial-up connections still exist, but they're few and far between. Most people don't have a laptop or a computer that even has a modem, an analog modem on them. So that would make it a little bit difficult to do a dial-up connection. I ran into that 10 years ago, in a situation like that where the remote access method that they were offering was dial-up, but the system we were on was connected to a cable modem and didn't have a modem installed in it, and it was just it was a huge pain to try to get all of that set up. So, and again, that was a decade ago, I think. And so we really have progressed now, and VPNs are going to far outweigh dial-up connections. Dial-up connections would still be used, maybe just in more remote areas or something where I only have dial-up internet. That's the only option that I've got. And even then, I think you'd maybe use dial-up internet to get connected to the internet to establish a VPN. So it wouldn't be a true dial-up remote access. VPNs are point-to-point connections between a client and a VPN server. Okay? It is utilizing the public internet, and so it is inherently less secure than a dial-up remote access connection. But because of that, it's going to be using tunneling protocols and encryption. So tunneling protocols encapsulate the data, and that just means package it. And the only time the data is unpackaged is at the source and the destination. So it's completely packaged as it's going over the public internet, and then it's encrypted, which ensures the confidentiality of the data. And now technically there's a couple types of VPNs. There's a remote access VPN, which is what we're focusing on. In the case of a remote access VPN, it is client and VPN server. The client actually has to have a VPN client installed. Now, in Windows, there is a VPN client that's inherent, but if you're using some other type of VPN server like a Cisco VPN solution, then you would have a Cisco VPN client installed. The point is, on a remote access VPN, the client must actually have software on it to enable it to connect to the server. And it's on the client that the tunneling and the encryption is occurring. When you get into the site-to-site VPNs, you're talking about a point-to-point connection, but it's a point-to-point connection between two devices, like two firewalls or two routers. In this case, the clients on either network are able to communicate with one another, but they don't have to have VPN client software in order to do it. It's the router that's encapsulating and encrypting traffic that has to flow through the VPN. So the site-to-site VPN is used for branch offices to a corporate office, branch offices to one another. The site-to-site VPNs really form a wide area network, so it's a different type of VPN than what we're going to primarily focus on here. When you configure a VPN connection, there are a number of different properties that have to be set, and these need to be set in the appropriate way so as to match the VPN server, or else we're going to have, we are going to have some issues. The encapsulation, authentication, and encryption, and this is really just talking about what is happening. So we've already said encapsulation is going to package the data All right, and the encapsulation is just dependent on the protocol that you use. That's not really a choice you make per se. Authentication, you are going to have different choices. You can use user level authentication using PPP, which is point-to-point protocol. Computer authentication using IKE, the Internet Key Exchange, which is a protocol within IPsec. And then data integrity and sender validation would be available using IPsec as well. So it's going to depend, as I said, again, on the protocol that is being used. Encryption, same thing. Microsoft point-to-point encryption is used if you're using PPTP as your VPN protocol. But then if you're using something else, L2TP or IPsec, then there's going to be different types of encryption. So those are just the properties of the VPN. They are choices that you make, but in the vast number of cases, it's a choice on the protocol that you're going to use, which then incorporates different authentication and encryption schemes. So what are those protocols? Well, we do have 4 different choices for tunneling protocols in Windows 10. Point-to-point tunneling protocol is available. The encapsulation of PPP frames in IP datagrams, it is using what's called GRE, or generic routing encapsulation. This is a long been a standard form of encapsulation for VPNs. The encryption is Microsoft point-to-point encryption, or MPPE. It is possible to have up to 128-bit encryption, and the keys are generated by using MS Chat version 2 or EAP TLS. EAP TLS is your extensible authentication protocol. TLS stands for Transport Layer Security, and it would allow you to use smart cards for authentication. Point-to-point tunneling protocol is the oldest VPN protocol that's out there. It really should not be used, if at all possible at this point, because it lacks in security in comparison to the other ones. Then you have Layer 2 tunneling protocol with IPsec. This allows you to encrypt multi-protocol traffic. It does not have its own encryption services. Instead, it relies on IPsec for encryption. But that does mean that the encryption is much higher. Okay? You can possibly use triple DES. That's that 3 DES, the data encryption standard, but it's much better to use the advanced encryption standard, giving you up to 256-bit encryption. The problem with L2TP is that it requires a certificate infrastructure. You're going to have certificates on the machines. L2TP with IPsec is maybe a little bit more common if you've got a site-to-site VPN. For remote access VPNs, it's very high security, but it's just somewhat difficult to implement. Windows Vista introduced an additional protocol that was the Secure Sockets Tunneling Protocol, SSTP, otherwise known as just an SSL VPN. This is a virtual private network that uses secure HTTP over port 443. The reason that this was developed, or one of the reasons, was that it eliminates issues with firewalls. Firewalls often block the ports that other VPN protocols need. 1723 for PPTP was somewhat common, but L2TP was 1701, and you also needed a couple of other ports open for the IPsec portions of L2TP. And so it was a little bit more cumbersome. And if you had a custom VPN solution or a third-party VPN solution, they would be using proprietary ports. It was also very common for those to be blocked by the firewall from an outgoing standpoint. So the client's on a Wi-Fi network and they can't make a connection because the firewall or the access point is not allowing that out. If you use port 443, then that's all eliminated because nobody blocks port 443. It's how we do anything securely over the internet. And so it's just kind of piggybacking on that. It encapsulates PPP packets in your IP datagram secured with SSL. This is a pretty common one. It does require a certificate on the server, and that certificate needs to be trusted by the clients, but it's just a general web certificate, cheap and easy to do. IKE, Internet Key Exchange, or IKE v2, is an IPsec-only style VPN that was introduced in Windows 7. It is using IPsec tunnel mode over UDP port 500 and encapsulate packets typically using ESP instead of AH. AH is authentication headers or authenticating headers. ESP is encapsulating security payload These are two protocols within IPsec, which is a suite of protocols provided to secure network transmissions, either locally or remotely. Okay, ESP is probably going to be used because ESP both encrypts and digitally signs. The digital signatures ensure the validity, the integrity of the data. The encryption ensures the confidentiality. AH only does the signatures, it doesn't encrypt. Well, with a VPN, we're always going to be encrypting. So that's why I say it's, the vast majority of the time it's going to be using ESP. The encryption most likely is going to be using AES, although triple DES is possible. Triple DES is just not as secure as the advanced encryption standard. So, as I said, this is an IPsec only type of VPN that is available on Windows 7 and later. It does provide additional functionality like the VPN reconnect option. When you do an IKEv2 VPN, you have the choice, you have a checkbox on the options that says, it configures the mobility time. And it's 30 minutes by default. So basically, if you have the VPN active, you lose your internet connection, the VPN goes inactive. If within 30 minutes you activate your internet connection again, the VPN will automatically restore itself without you having to go and reconnect. Okay, so for somebody who's maybe using a cellular data card or just traveling between locations quickly, transferring between one Wi-Fi hotspot and another one, that's very beneficial because it just cuts down on the time that it would take to reconnect.